All right, let's dive into one of the weirdest, most backward puzzles in all of astronomy. It's a story where all the names are mixed up, but once you untangle it, it tells you exactly where, well, everything, including you, comes from. Okay, so get this. The very first stars to ever exist, we call them population 3. The next generation of stars, population 2. And the youngest generation, which includes our own sun, yeah, that's population 1. It makes absolutely no sense. It's like calling your great-great-grandparents Gen Z. So what happened? How did we get a naming system that feels completely upside down? To figure this out, we have to become detectives. And the first clue isn't found by looking at the age of the stars. It's actually found by looking back into our own history. I want you to picture this. It's 1944. Los Angeles is completely dark, thanks to mandatory wartime blackouts. It's a pretty tense time on the ground, for sure. But for astronomers, that total darkness was an incredible gift. An astronomer named Walter Badide used that perfectly dark sky to point a massive telescope at our galactic neighbor, Andromeda, and what he saw changed everything. Peering into Andromeda, Body realized that not all stars are created equal. First, he saw these incredibly bright, blue, dazzling stars in the galaxy's spiral arms. They were the most obvious things there, so logically, he called the first group he found Population I. Easy enough. Then he looked closer and saw these fainter, redder, older-looking stars hiding out in the center and the halo. And since they were the second group he identified, he named them Population 2. And boom, there's our answer. The names are based on the order of discovery, not their actual age. But the mystery doesn't stop there. Because decades later, scientists found an even bigger difference between these stars, a chemical secret that would unlock the entire history of the universe. And that secret is a concept called metallicity. Now, this is where astronomers get a little weird with their language. When they say metals, they aren't just talking about iron and gold. To an astronomer, a metal is literally any element that isn't hydrogen or helium. Oxygen? A metal. Carbon? That's a metal too. A star's metallicity is basically its chemical fingerprint. It tells us how much of that heavier, recycled stuff it's made of. And this is where it gets really cool. These metals are basically the ashes of previous generations of stars. So in the universe, being polluted with metals is a good thing. It's a sign that you come from a long, rich family history. And all that cosmic pollution, well, that's the secret ingredient you need to build planets, and eventually to build life like us. Okay, so we've got our clues now. We've got the historical names and the chemical fingerprints. So let's finally put this family history in the right order and meet the three great stellar generations. So, after astronomers had sorted out population 1 and 2, their models of the early universe showed there had to be an even earlier generation of stars, a first generation made from nothing but the pure, clean gas from the Big Bang. But, well, the names I and II were already taken. So, with a kind of cosmic shrug, they named the very first stars ever population 3. And you have to understand, these first stars were nothing like what we see today. They weren't just big, they were true cosmic monsters. We're talking anywhere from 100 to 500 times more massive than our own sun, just absolute behemoths. These were the universe's founders. They were the rock stars of the cosmos. They lived fast and died young. Made of pure hydrogen and helium, they burned insanely hot and blew through their fuel in just a few million years. But when they died, they went out with a universe-altering bang, exploding with enough force to cook up the very first heavy elements and seed the cosmos for everything that would come next. Now, from the ashes of those giants, the second generation was born, population 2. These stars formed from gas clouds that were just lightly seasoned with the metals created by those first stars. They're ancient. Many are still around today, almost 13 billion years later. They're like living fossils, hanging out in the quiet suburbs of the galaxy, holding on to the chemical secrets of the universe's childhood. And that finally brings us to our generation, population I. These are the young, modern stars, like our sun. They're metal-rich because they're made from gas that's been recycled over and over again through billions of years of stellar life and death. And all those rich, heavy elements, that is exactly what you need to form rocky planets, planets like our own. Without the legacy of Pop 3 and Pop 2, we simply would not be here. So, let's put it all together. The naming system is backward, but the story itself is crystal clear. You start with population 3, the founders, made of pristine, clean gas. They create the first metals for population 2, the pioneers, and they in turn enrich the universe for population 1, the moderns, which is us. Each generation builds on the last.
So, why does all this matter? I mean, it's a fun bit of cosmic trivia, right? Well, it matters because this story isn't just happening out there in space. It's happening inside you, right now.
Think of it this way, like building a city. The massive population 3 stars were the first pioneers. They arrived in an empty wilderness and built the first essential infrastructure, the heavy elements. Then came the population 2 stars, the villagers, who used that foundation to build the first simple towns. And then there's us, orbiting our population I star. We're the city dwellers, living in a complex, modern metropolis built from the incredible wealth left behind by all the generations that came before. And that is the ultimate takeaway here. The whole naming thing is just a quirk of history. The real story is that the iron carrying oxygen through your blood, the carbon that forms the backbone of your DNA, every single heavy atom that makes you, was forged in the heart of a dying star billions of years ago. We are, quite literally, made of stardust. It's a pretty humbling and incredible thought, isn't it? We are the result of a 13 billion year long cosmic recycling program. And that leaves you with one final, awe-inspiring question. If we are made from the ashes of dead stars, what amazing new things will the universe eventually build from ours?